Hello all. In this video, I would like to explain a fundamental machine learning concept, bias and variance trade-off. I would like to start with conceptual, graphical, and mathematical definitions, bias and variance trade-off. So starting with conceptual definition, suppose we are provided with a bunch of data points that represents heights and weights of bunch of people. So for a particular red point, height is represented and corresponding weight is represented to the red point. So in machine learning, our primary objective is to learn the relationship between the height and weights based on the data we are provided with. So we can think of machine learning model to be very simple, or it can be very complex. So what if our machine learning model is very simple? Suppose it is a line that passes through a region. So in that case, it won't learn the true distribution of these data points. So for certain data points, this line would be further away, and for certain data points, it will be very close. So here bias would come into picture. So for this simplistic model, there will be an error involved because of less complexity of machine learning model. So this error is known as bias. Now what if we try to learn a complex machine learning model that fits our majority of points? So here by fit I mean the true relationship between height and weights. So best line would go over and pass through majority of points. So in this case, even though our model learns very well the distribution of training data, but when we are provided with a new sample point, it will fail badly over that sample point and give us an error that is known as variance. Further, I would like to emphasize that bias is calculated over training data and variance is calculated over test data. Now over to graph. Continuing with our discussion with graphical definitions, consider this plot which represents model complexity versus prediction error. So you can see with increase in model complexity, prediction error tend to decrease over training samples. And for test samples, prediction error first tends to decrease and then increases gradually. So here, when our model is low in complexity, prediction error is high because we have made simplistic assumptions. So this represents high bias and low variance. As we increase model's complexity, variance tends to increase and bias tends to decrease. Okay. So further, we can explain the trade-off graphically using this diagram. So here the center of this bullseye represents best model. So this particular bullseye represent low bias and low variance because majority of our model lies within this center of the bullseye. So further, these two figures represent model that are not best and not worst, but somewhat in between. So this particular model has high bias and low variance, and this particular model has low bias and high variance. So when we have high bias and high variance, so our points will be further apart from our best model represented by the center of this bullseye. So this represents worst model and this particular represents best model. Going over to mathematical definition, suppose the value we want to predict is y represented by y. So our machine learning model will try to approximate the relationship between the input x and y using a function f. So suppose the true relationship is defined by function f and this function is approximated using f cap. So error will be the mean scared error, that is the scared difference and of each sample and taking average over all the samples represented using this equation. We can expand this and rearrange this equation to get equation for bias and variance. So as you can see from the equation of bias, bias calculates how far on average our model's prediction is from the correct value. Okay, and variance measures how much our prediction varies compares to average prediction of other models. Further, I would like to ask, can error ever be zero? That is, can bias and variance can be zero? If not, is there something which is missing in this equation one? Okay, so I will like to stop this video here. Thank you, and we will meet some other time.